user, welcome to my channel Learning with Khatak. Today we are going to present a series of videos by covering practical machine learning walkthrough. This is basically a workshop type. This is the part 1, and we will cover the practical machine learning approach within 3 or 4 video lectures. So basically, if you have data sets, then first the data set will be divided into 2 parts. This is training data set, testing data set, and then training data sets will be sent to the cross validation process. After the cross validations, the best parameter will be selected, and then the model will be retrained, and then finally the evaluation will be done by providing the test data to the final model. So here we are working with the IRIS data sets. This is the multi-class data sets with balanced distribution of samples. So you can download the datasets from the UCI machine learning repository. So the important feature inside the datasets is sepal length, sepal width, sepal length, petal length, and petal width. So there are 3 classes in the datasets. These are the 3 classes: iris, setosa, versicolor, and virginica, and 4 features with equal samples. Total samples are 150, while each class contains 50 number of samples. Okay, so here we are going to load the datasets from the sklearn datasets. This is basically save bunch object containing iris dataset and its attributes. So if we run this code, let me clear all these cells first to show clear cut. Okay, now let me run this. So this is sklearn.utils.bunch. Okay, now then printing the shape, total number of samples and features. How many features are in the datasets, how many number of samples in the datasets. So if you look at this, it gave me 149 samples while 5 features. But we have claimed earlier that there are 150 samples in the datasets with 4 features. Then how is it possible? Okay, total samples here is 149 instead of 150, and features are 5 instead of 4. Why? So wait for this, that what we had mistakes here. So before getting the 150 features, displaying some sample data without proper column name. So we want to display some data. If you look at this, this is the data inside the datasets, in the IRS datasets. If you look at this, without proper column name. So the column name is just some values, 5.1, 3.5, and so on. So why these columns names are not properly? So wait for this information about the column names. We want to get some information about the column, that how many values inside the columns, and what is how many null values, and what is the data type of this. So it tells me that total 149 columns and all types are float. Okay, so now what we have did here, that get 149 columns and 5 features instead of 4. So now let's me do it. These are the proper features, column names: sepal length, sepal width, petal length, petal width, and total number of rows are 150 and 40. Now how to get these proper column name and the number of features with the number of samples. Now what we have to do, that look at this again. I'm loading a data sets. This time I'm providing header 0 and pass data is equal to false. So if I run this, now look at this, I get 150 features and 150 number of samples and 5 features. 5 features, basically 4 are the features: sepal length, sepal width, petal length, and petal width, and the fifth one is basically the target class, that is setosa, versicolor, or virginica. Okay, now 4 features in target class. Now we want to show that how many features are there. So if you look at this, there are 4 features basically: sepal length, sepal width, petal length, and petal width. This is the target class. So features are 4, these are the features, and this is the target class. Okay, now data in the IRS datasets. If you want to look at the data, what type of data is there? So look at this, this is the data. So there are 4 features only, there is no column here in, because data is called features while target class is called label data. Okay, now then how classes are represented? So if you want to know that, if you want to show that how the classes are represented inside the datasets, then total 3 classes in the datasets by displaying iris the target names. By the target names contain the total number of classes, and then each class is represented 50 times, that how many samples are inside in the class. So if we run this, if you look at this, So total 3 classes in the data set, that is Setosa, versicolor and virginica, and then each class represented 50 times. If you count the 0, so it means the virginica, sorry, the Setosa is represented 50 times. Similarly, the versicolor represented by 50 times if you count the 1, and similarly if you count the 2, this is the representation of virginica class. This is also represented with the, by 50 samples. So check the types of the features and responses. Now we want to check the data and the relevant target classes. So if you look at this, they both belong to class numpy and array, and numpy and array. So okay, now here we want to show that if I run this, this give me that total number of samples is 150 with the features of 4. So check the shape of the features. First dimension is the number of observations. So these are the number of observation, and the second is basically the second one is number of features. So here in this case 150 is the number of samples and 4 are the features, and similarly total samples in 3 classes, how many samples are there in the 3 classes? 150. So this is very simple explanations of the shape of the data sets, that how many features are there and how many samples are there and how many classes are represented inside the data sets. Now store feature matrix in X, that is value of the columns. Now before classification, we have to store the number of features or all the features inside the X, and the number of classes or the sample represented the classes will be represented in Y. So if I run this, look at this, store all the features in X data set. So this is now becomes X data sets. Here is the X data sets, all the data is stored in X data set with the 4 features. Similarly, we will store responses vector, means classes, number of classes in vector Y. So here if we run this, okay, if I run this, look at this, this is the representation of all the 3 classes. Each class have 50 samples. So if we count the number of zeros, they are 50. Similarly, the number of representation 1 is also 50 and 2 is also 50. So means all the 3 classes have equal distribution of samples, means every class contains 50 number of samples. That's why we call it a balanced data sets. But since there are 3 classes, also we call it a multi-class data sets. Okay, showing some samples with 3 nearest neighbors. So this is a simple graph. We will explain these graphs later on, but look at this. If this is the training class 0, the blue shapes representing the training class, and then the purple are the this is the training class 1 and test prediction, and then test predictions. This basically diagram will be explained later on. So creating KNN objects. So now in the next part we will create how a KNN model will be created, how a KNN model will be trained, and then how the prediction will be made, and then finally we will see the accuracy. And then in part 3, we will again load the data sets by applying some different techniques here. So wait for the next part 2. Thank you very much for watching.